bacteria that drives the resistance, and I'll show a video about that too. Okay, so here's just a graphical representation, if this is an easier way for you to visualize the 4 different mechanisms. So this is in a different order than what I have here, but that's okay. So number 1 here, blocking entry. So again, here's your antibiotic. It needs to get into the cell in order to perform its activity, but for whatever reason, the bacteria has developed a way to prevent that antibiotic from getting into the cell. Okay, so that's number 1. Number 2, inactivating enzymes. So what that means is the bacteria has developed an enzyme. It now produces an enzyme that basically, once the antibiotic gets into the cell, it basically chews up this antibiotic or cleaves it in a way that makes it inactive. So that's the second way. The third way is, let's say this antibiotic is directed against a certain enzyme within the bacterial cell. The bacteria can actually alter that enzyme so that the antibiotic can no longer bind to it and have its effect on the enzyme. And then the fourth way would just be efflux of the antibiotic. So the antibiotic gets in, the bacteria recognizes it as the antibiotic, and basically just spits it right back out. Okay, these are the 4 main mechanisms of resistance. So this is what an infection that gains resistance to an antimicrobial would look like. So here's the initial infection. On day 0 is the initial infection. At day 1, the patient starts taking antibiotics. You can see the bacteria count is very high. Eventually, because the antibiotic starts to work, bacteria count goes down, but something happens during this time frame. Either, again, there's a mutation, or there's some kind of resistance gene that gets acquired by the bacteria, and it gains resistance to this antibiotic, and the bacteria start to come back up. And what you can see here, this is the antibiotic resistance. This is basically how much antibiotic it would take in order to prevent the bacteria from growing more. And you can see this resistance is causing the bacteria, the need to increase the amount of antimicrobial significantly, up to the point where you're basically at your maximum level. So you can't go any higher than this without it being toxic to the patient, and bacteria is still able to continue to grow. Okay, so again, this is what it would look like if the bacteria infection gained resistance. So at this point, you'd either need to change antibiotics or start to think of a different regimen. So what are the major drivers for antibiotic resistance? So the number 1 reason, and I'll give my little speech about misuse of antibiotics, because I don't think people are aware exactly of the harm they could be doing by misusing antibiotics. And it's not just patients, it's doctors as well. So the misuse of antibiotics basically selects for resistant mutants. So if you have a bacterial infection where you have, I'm just going to throw out a number, 1 million bacteria cells in your body, and let's say 1 or 2 of those bacteria are resistant against an antibiotic. Okay, if you don't use the antibiotics appropriately, you'll kill off the ones that are susceptible, but those ones that are somewhat resistant will remain behind and eventually divide and start to overpopulate, and now you have an infection that is twice as strong, that is resistant to an antibiotic. Okay, so the main reasons why that happened, people using outdated or weakened antibiotics. So I've heard people before, maybe even people in my family, who I had to scold about doing this, but they had antibiotics from an infection they had 3 years ago, and they took it out of the cabinet and said, oh, I'm not feeling well again, I'm just going to take the rest of these antibiotics. Okay, again, what that does is that basically kills off the weak bacteria and lets the strong ones survive, and then those strong ones repopulate, and now you have a stronger infection. Okay, so again, it seems kind of silly the way I describe it, but people are doing this all the time. Okay, so again, if you get prescribed antibiotics for whatever reason, if you have some left over, which you really shouldn't, and I'll get to that, if you do, just throw them away. Don't save them for the next time you don't feel well. Okay. Another thing, and again, this is somewhat on the patient, somewhat on the doctor, using antibiotics for the common cold and other inappropriate conditions. So again, if you have a cold, it'll go away in a week. Okay, you're not going to die. You're just going to blow your nose a little bit, and eventually it'll go away. Some people walk into the doctor's office and demand that they get antibiotics because they don't want it to take a week. They want it to take 5 days. Right, and then they want it to be gone. They want those extra 2 days to feel healthy. Okay, doing that every time you take antibiotic that you don't need to take an antibiotic, you are running the risk of, again, allowing these handful of resistant cells to overpopulate the body. Okay? Using antibiotics in animal feed. So, you feed the chickens or the cows with antibiotics to prevent them from getting infections. Then we eat the chicken or the cows, and we're taking antibiotics without even knowing it. So again, every time you take a little bit of antibiotics, you're killing off the weak ones, letting the strong ones survive. So that's part of the reason. Fourth one's probably the biggest one, failing to complete the prescribed regimen. I think a lot of people, if not most people, get prescribed an antibiotic and they say, take this for 14 days. They take it for 5 days and they start feeling better and they just say, okay, I'm better, I don't have to take the rest of this. Okay. Again, what you're doing there is you're killing off most of the bacteria, the ones that are weak and susceptible to the antibiotic. And you do feel better because you probably killed off 99% of the bacteria. Okay, but again, the strong bacteria that were somewhat resistant to that antibiotic remain behind, and you have the potential to get a secondary infection. So I'm sure it's happened to at least one person in this room, if not a lot of people in this room, where you are sick, you take an antibiotic, you stop taking it, and then 2 weeks later you get sick again. And it's worse the second time than it was the first time. Okay? That's what's happened because, again, people think because they feel better, they don't have to keep taking medication. Okay, it's not aspirin. Okay? It's not something that, I don't have a headache, so I don't have to take aspirin. Okay? That's obvious. If you don't have a headache, you don't have the symptom. From an infection like this, you might not have any symptoms and still have an active infection. Okay? And the fifth one is the worst one. I can't believe anybody's doing this, but I actually know somebody that did this. I actually know somebody that gave his leftover prescription to his 10-year-old daughter because she had a fever. Okay? So again, using someone else's leftover prescription, I don't even have enough time to tell you how stupid this is, but first of all, it's not a full dose. So again, you're not getting the full dose because whoever had it first probably took some of it. Okay, so you're not getting the full dose. It's probably not the right antibiotic for whatever your infection is. Not every fever is the same bacteria. Okay, it's probably old, so it's probably weak. Antibiotic, it's probably past its expiration date. So again, I hope I'm not having to tell any of you guys this. I hope a lot of you guys understand this, but this is for you guys to go, and if you hear people doing this, or the whole thing with MRSA probably never would have happened. And again, MRSA is this strain of infection of staph that people get when they go to the hospital that's resistant to all these different types of antibiotics that's killing a lot of people. And things like that probably wouldn't happen if these 5 things weren't happening constantly. Okay, so you guys can go spread the word and make sure that this isn't happening. Okay, so I'll show a couple videos here about the different kinds of resistance.
A big challenge to medical science today is the growing problem of antibiotic resistance. A pathogen that is resistant to a particular antibiotic will not be killed or inhibited by that antibiotic. It has gained that resistance either by random mutation or through gene transfer from another bacterium. In a particular population of bacteria, there may be a few cells that are resistant to the effects of a particular antibiotic. When the patient is given a particular antibiotic, that drug will kill or inhibit the growth of all the sensitive bacterial cells. This allows the resistant cells to multiply freely in this less crowded environment. One way that bacteria can acquire resistance genes is through mutation. If a mutation occurs in a sequence of DNA, this could result in a different amino acid sequence. Consequently, this different sequence could produce a new enzyme, perhaps one that can interfere with the action of an antibiotic. Bacteria can also acquire resistance genes by horizontal gene transfer. One type of horizontal transfer is transformation, in which a cell picks up a piece of DNA from its surroundings. Or a bacteriophage can transfer the resistance genes from one bacterial cell to another in the process of transduction.
Okay, so we learned about that.
Finally, resistance...
We didn't learn about that, so I'll stop it
Bacteria can resist the effects of antibiotics through several mechanisms. They may secrete enzymes that destroy the chemical structure of the antibiotic. For example, penicillin-resistant bacteria produce an enzyme called beta-lactamase. The beta-lactamase enzyme breaks the beta-lactam ring in the molecule of penicillin and related antibiotics, such as cephalosporins. This prevents the antibiotic from disrupting the peptidoglycan cell wall structure. Other bacteria prevent antibiotics such as tetracycline from passing through their cell membranes. They do this by changing the structure or charge of pore proteins. Even if the antibiotic can penetrate the cell, a resistant bacterium can make it impossible or more difficult for the antibiotic to bind to its target. Sulfonamides are antibiotics that compete successfully with PABA for an enzyme binding site in the folic acid synthesis pathway. Resistant bacteria may have evolved an enzyme with greater affinity for PABA, thus making the sulfonamide less effective at blocking the folic acid pathway. Other resistant bacteria have developed a method to obtain molecules they normally synthesize directly from their environment. Therefore, they aren't affected by the blockage of the biosynthesis pathway. Finally, some resistant bacteria have membrane-localized efflux pumps that remove some antibiotics from the cell. Some resistant bacteria have a greater number of efflux pumps, thus increasing their ability to eliminate the antibiotic. In some cases, bacteria have also been able to increase the spectrum of drugs that are eliminated by these pumps by making pumps less specific.
Okay, so that covers all of the four mechanisms. So just a couple more things. So a lot of times we use a combination of drugs. We don't just use a single drug. So, logically you might think, okay, if you have one drug that works or two drugs that work, you put them together, they're going to work twice as well. If you give them together, that's not always the case. Sometimes they interfere with each other. Okay? Synergism is actually when you take the effect of two drugs and you put them together, and then their effect together is greater than the effect of either one of them alone. Okay? So if drug A gets rid of 50% of the infection, drug B gets rid of 50% of the infection, if you gave drug A and B together to get rid of 100% of the infection, that would be synergism. Okay? Antagonism is the opposite. When you gave two drugs together, it's less than the effect of either alone. So the same example, drug A gets rid of 50% of the bacteria, drug B gets rid of 50% of the bacteria. If you gave drug A and B together, you'll get rid of 25% of the bacteria. Somehow they're interfering with each other. Okay. So this is just showing an example of synergism. So it's a little bit hard to see, but you have one drug here on this disc, one drug here on this disc. The zone around each of the drugs is clear, but it's still a little bit gray. If you look in the area where the two drugs come together, there's less bacterial growth. So again, this would be synergism. The combination of the two is greater than either one by itself. Okay, I think this will be the last slide actually I go over. So this is just antibiotic safety. We'll come back to this at some point later, but there's a therapeutic index, basically meaning the risk of taking a drug versus the benefit. Okay, so depending on the benefit, the higher the benefit, the higher the risk can be. Okay, so for instance, if you went to the doctor with the flu and he wanted to give you an antibiotic, there better be very little risk involved with doing that, right? Because your alternative is you could just stay at home and sleep a little bit and eat some soup and it would go away by itself. So that you wouldn't take anything that has the possibility of giving you liver disease, right? Because that risk is not worth the benefit. However, there are some infections that are extremely deadly that if you didn't do anything within a couple weeks, you would die. So in that case, you'd probably be willing to take an antimicrobial that has some pretty nasty side effects because the alternative is take nothing and die within a couple weeks. Okay, so the therapeutic index is basically for any given drug and any given disease, that combination, what is the risk of taking that drug versus what is the benefit of taking that drug. Okay, so again, some drugs have a lot more significant side effects, and you're only going to use those drugs for very serious and severe diseases. Okay? Does that make sense, everybody? Okay. So we're going to skip over the rest.